Now, before we dive into more of these recursion at runtime examples, which are super useful, before we do that though, I want to talk about one concept, which is how the order works when the interpreter evaluates your code. It's a mouthful. I think just by giving you some examples, you'll be able to understand it fairly quickly. So here's a quick one. Gotta have the semicolons, great. Okay, I'm going to invoke 10. Now, what happens in the interpreter's mind? Well, we know from the last video that a runtime instance of 10 is created. So the interpreter actually runs 10. Okay, so 10 runs. Now, here's my question. Line 2 is a return statement. And it's returning the number 5 plus an invocation of the function 5. Now, this is a little tricky, but there's 3 things that could happen first on this single line of code. It's possible that the first thing that happens is we return. That could be the first thing that happens. Or the first thing that happens could be that we add 5, the number 5, we add the number 5 to the invocation of the function 5. The third thing that could happen is we actually run the function 5 and return whatever it returns. Which one do you think is going to happen first? Is the return going to fire first? Is the addition going to fire first? Or is that function 5 going to fire first? Well, let's just consider. Can we return first? Well, you can't return a mathematical operation. I mean, a mathematical operation, that's not a thing, right? That's not a value. Like, imagine if you were going to the donut store and you said, Nick, how many donuts do you want? And I said 5 times 5. There's no such thing as 5 times 5 donuts. You can do the equation and get to 25 and then get 25 donuts, but you can't have a box with 5 times 5 donuts in it, because 5 times 5 isn't a number. It's an equation. It's not yet a value. You have to run it first, and then you actually get a value. So in the same way, we can't return 5 plus some. We can't return an equation because it's not a value. It's an expression. It's like an equation. It's not a value yet. So we can't do the return. Okay. What about 5? Can we run 5 plus 5 first? Well, 5 plus. Here's the issue. A function invocation is also not a value. This actually isn't yet anything. Think about it. It's not a value. Values are numbers or strings or arrays or objects or booleans. It's none of those. It's called an expression. An expression is something that will become a value, but is not yet a value. It will lead to a value. It will produce some value when you run it, but it's not yet a value. Right? So again, any arithmetic, 5 plus 5, that's not a value. It's not a number, but when you run it, it will become a value. That's called an expression. Okay? Expressions evaluate and are replaced by whatever they return. So in coding terms, just to make a little sidetrack here, if I was to console log 5 plus 5, we can't actually run console log until we evaluate this expression. We don't know what to console log yet because we don't know what this is going to be. It's not a number or a string or an array or an object, so we don't know what it is. It's an expression, which means it will become a value, but first we have to run it. And in the same exact way, an invocation of a function is not a value. We can't return it. We can't add it until we figure out what that function returns. Okay, so what's the next thing that happens? This function gets invoked. So an instance of 5 is created in memory. We go down here to return 5. Now, this is key. This is fundamental here. I want you to remember this line. I'm going to say it once, think about it, and then I'm going to say it one more time. At runtime, a function invocation is replaced with whatever that function returns. At runtime, a function invocation is replaced with whatever that function returns. So here's my question. We're returning 5. Where does that 5 go? Where does that 5 go? Well, we know the rule, right? At runtime, a function invocation gets replaced with whatever that function returns. This is the invocation. It returns 5. So literally, in the computer's mind, it gets replaced with the number 5. And this invocation disappears from its memory. So now all it does is it just adds these up. It takes this expression and turns it into a value, turns it into 10, and 10 is returned. Okay? So to give you the rules that I just laid out one more time, there are expressions and there are values. Expressions things like equations, things like function invocations, things like referencing a variable. None of these 3 things are actually values. None of them, they're not numbers, they're not strings, they're not objects, they're not arrays. We can't do anything with them. We can't return them, we can't add them together, we can't give them as an argument, we can't do anything until they get replaced with a value. Okay? Now values are, actually we'll just make this numbers, strings, objects, arrays, booleans, right? So this expression on runtime evaluates to a number, and then we can do stuff with it. This function at runtime, the interpreter goes into the function, finds what it returns, and replaces it with whatever it returns. Let's just say it's a string called Nick. A variable at runtime gets replaced with whatever that variable is pointing to. Let's say it's just pointing to an array, an empty array. These are all values. And expressions are code that at runtime turn into values. So when you see a function invocation, remember, you can't return that yet. You can't add it yet. You can't do anything with it yet until the interpreter finds what that function returns and replaces it.